Live from the Tanzu TV studio, it's Tanzu Tuesdays. Your host, Tiffany Jenigan.
Hi there. Welcome to today's episode of Tanzu Tuesdays. If you haven't been here before, welcome. And if you've been here before, nice to see you again. Thanks for coming back. So next week, we have an episode on cloud native build packs. So that's with Daniel Makuza, and that'll also be at the same time at 12 p.m. Pacific time. So you can take a look at the episode on tanzu.tv/TT, and it's episode 59. And then the week after that, we're taking a slight break in a way, like we'll be doing Among Us. You may have seen our previous episodes where our team just basically tried seeing what would happen and who would be an imposter, who would get murdered, etc. Playing Among Us. So we haven't done this in a while, and we figured that we would try doing it again and see how that goes. So that will be 2 weeks from now. So yeah, for all the things that we have, go to tanzu.tv, and we will have our next Spring One tour in July. So if you can also see that on tanzu.tv to check out what will be happening there. The first day is a talk, and the second day is a workshop that you can register for. You won't need your own Kubernetes cluster. You'll just need to have your laptop and internet, and all those things will be set up for you. So feel free to sign up for that. And basically, if you want to see any of the previous episodes for things that we have either for Tanzu Tuesdays or for some of the other shows we have, again, that'll be on tanzu.tv, and those will end up on YouTube as well. So today we have Dan. So welcome to Tanzu Tuesdays.
Thank you for having me. So
you're saying that you've seen some of our episodes before, but this is the first time you're actually on it.
Yes, I watched them. I usually try to watch them during the day. Before they were like at 4 p.m. Eastern time, so a little bit easier now. It's a little bit, during the day. But I watch them on YouTube when they come along. Always interesting for me to see something new. I'm a little bit more curious by nature, so anything new is a step forward.
Shiny thing.
Shiny toys, like, come on. We're always going to be children in this industry. We always like the new things. We always like to learn something new, try something new out, see what's new, because what we know today, we learned it yesterday. We want to see what's coming up tomorrow.
And there's just like there's constantly either a new product or a new feature, and it just, there's always something. There isn't a single day that goes by where there isn't something that is new.
Oh, this, and especially in like aspects like native. I had a workshop at UConn Plus, so everything was working 0.9.2 and samples and so on. But then 0.10 came out 8 days ago, and it brings these new cool features. So it would be a pity not to try them out. Try them out, see what works, see is there something you might want to change, or you might find some new idea. It's always constant, and if there's something new, you're always thinking right away, can I apply that to my regular work, whether it's with clients or your pet project or open source contribution, whatever this is. This is never a dull moment.
Yep. And then you get to figure out, hey, is this thing work? Did I just like change all my stuff and then it's not ready and I broke it?
Well, many times things work, and then it kind of like makes you troubleshoot a bit, and you kind of like welcome a few things not to work, especially like when things are like in beta and they're ramping up, because it makes you dig a little bit. Then you're understanding it better, and then you document it. I take notes of the things I see, and then maybe some of these we'll share today, but others are good to know. It's like in the university, what do you remember from there, how to look for information. So with this, it's like with 0.10, which just came out like 8 days ago, 2 great new things coming up, improvements and so on. But there were like a couple of small things which they're not at. It's not that they don't work. It's they're still evolving. So then, is there a way around it? Yes, there's a very simple way, and it's natural, but we want to understand this. Once you go, you start comparing. Oh, how was it yesterday? How was it today? What has changed? What have I learned out of this?
Mm-hmm. And so, like, random question. So say if you could travel anywhere you wanted and just like have a vacation, where would you want to be?
Well, I traveled around the world in different places, but my next vacation, which was broken up because of COVID, would be a hiking tour through Norway. Stay each night in one of these little huts. They're all World Heritage sites, and just go and hike, like 8 days away from electronics and gadgets and so on. So Norway is the next one on my list whenever travel will resume.
That sounds really fun. Yeah, the only part of Norway I've been to is Oslo.
I haven't been to the Nordic countries. My parents, when I was a kid, I was born in Romania. My parents were the first people from Romania to cross the North Polar Circle. That was an expedition back in the 70s when we didn't have the cars of today and the amenities, maybe. So that was one of the things I remember. I always wanted to go to that part of the world, but it never happened. Alternative would be Japan.
I want to go to Japan.
Hiking through Japan. Olympics, cool, sure, it's lovely. But there's this 3-week hike through Japan, the hidden places where you don't see almost anybody. You just go from one temple, one hut, one forest to another. It's that would
So
be
nice.
Something different than what we do. We live amongst electronics. We have every gadget in the world. We can watch in 4K, 8K, whatever, everything. But sometimes maybe we just need to kind of like, disconnect and explore the things we like.
Yeah, I'm going to be in San Francisco, so my first trip, and I'm going to see how well I can disconnect from things. Obviously, I'll have my phone to navigate around places, but hopefully I can just like not worry about homework and stuff.
Well,
Little helper vote says, I'm trying to eat sushi and drink whiskey in Japan.
Oh,
that sounds like a good time.
Introduced it by some friends who traveled to Japan and brought on back, nicely wrapped. It was like it was an incredible experience. But to travel, you learn from each country something else. And I expose my children to travel, so they have to see that, and you have to go and take the off-beaten path. Go stay in a city for a week or two. Don't take subway or bus or car or so on. Just walk the street, see the pulse of people. You're never going to experience Paris if you don't go at 7 a.m. and grab a baguette hot in a bakery.
I definitely didn't do that. I've been to Paris multiple times, but I like sleep.
It's the idea of exploring, and that happened also in what we do regularly. You want to see the things which are not all the time published, not just, hey, here, show me something under the hood, right? Let me understand also, when you see how people live. It's interesting. You go to South America and you talk to people and you see their joys, their sorrows, their things which they're interested, the way they're interested in what you can share with them, and you're interested to learn from them.
Speaking of learning, how about we learn some stuff from you today?
Well, we'll see if anybody learned something from me today, but we're going to go through some samples, and we're going to look at native images in a slightly different way. We'll have a quick recap of what native images are, but we want to see if it is as simple as just changing some configuration and building a native image. Are there things which we need to know? Are there things which could trip us up? But in the process, can we learn also new things? Are there things which maybe from our programming experience, maybe we're migrating an older application, or we're helping a client decompose a monolith and migrate it to microservices, but also for ourselves. Can we become better programmers if we learn one or the other things, or should we be aware of some hidden dangers which could happen? So that's what we want to explore today through a number of samples. And we're not going to build too much because native images take quite a long time to build. So we have some pre-built images, but we go through all the samples. So that's where we want to go, and I hope this is something of interest, and this is something which should be followed in detail. So the materials at the end, I will share the materials from the workshop, which I gave not just at QCon, but also internally through our architecture community. And those samples take things in a more methodical way. For each dynamic feature, we can see how you do it with Graal, how you can do it with Spring Native. Have some best practices, have some samples, but follow them along so that you don't get lost. You can compare, because many times you see a workshop, it might be incomplete or it might be just look for more. How about you take one, run it one by one, see how this goes. And that should always be like a mini reference. Of course, it changes so fast that we have to update it all the time. I guess every few weeks we'll have something new. But I'll share that, and that should be just like a little reference, which anybody can watch later and say, well, I want to explore this particular aspect. Here's how you should actually do it and not get lost through it.
Sounds good. I'm gonna disappear now.
Okay, so I will share my screen. I will share my, I hope everybody can see it. I will share my Mac screen so that whoever is viewing it has the same experience. So what are we going to look at today? So we want to compare a little bit just in time with ahead of time, understand class initialization, but in the context of native images. And then we want to see, are there any limitations? I want to see their limitation. There are dynamic features which are making application behave differently when we use them in native images. Then we want to see what is different in Java, in some Java features in when we build native images. And in the end, can we learn some good practices or maybe improve the way we write our code? So before we go through the building blocks on the road to native images, how about we take the tried and trusted pet clinic application. So let's start this application, and we have some pre-built images. Building of native images, as we all know, takes some time. So we're just not going to build them. We see it starting up. It starts in like 3 seconds, but here's our pet link. So this is all good. When we start the native image, let's start this and let's see what we observe. We observe like a super fast start time, 150 milliseconds. Is the app still there? Oh, seems to be there. But then when we moved in between these two, was it just a seamless change? Did we just change Maven or Graal and put a different plugin? Well, let's take also a failed example. When we start this up, it's built as a native image, starts super fast, but we see there is a problem here. And if we're trying to go through the application, says, okay, something has happened. So this is actually not good. Now we're going to try and understand what can actually trip us up. But before that, let's have a quick look to some of the building blocks of native images. So let's compare just in time with ahead of time. So in traditional apps, we compile Java code into a class bytecode, we archive it in a jar, and then we want to execute it. At runtime, the bytecode is executed by the interpreter. The execution will always be slower because it takes time until you translate until you interpret every single piece of bytecode. And the hotspot technology will help us transform parts of the code into native code, the areas which are the heaviest execute. So it improves performance, improves over time. Startup was slow, but also build time was actually fast. Then we execute the code. Now, in ahead of time, we do the same process. We compile the code into bytecode. We have our jar, but now we want to transform this ahead of time into a native executable. So we want to build this every single pass of the code into a native executable. When we move to the native runtime, it should start fast because it's understood by that on that OS and that host. It's understood. One immediate benefit: the native image does not depend at startup on the number of CPUs because JVM needs to interpret code, native does not. Yes, it takes a long time to build, but on the other hand, startup is fast and the usage is right away. First request executes as fast as request number, I don't know, 100,000. There are some major differences as we built this image. We have to deal with a number of, we have to make some closed world assumptions. So we perform a static analysis from the main entry point of our application and will remove aggressively any code which we don't need. But the class path is fixed. We cannot lazy load any classes. Some code will build at runtime. There are no runtime optimization because everything is in that image. And we require some upfront configuration for proxies, reflection, and resources. What tools do we have at our disposal? So GraalVM is the basic idea is it's a virtual VM that can execute all languages. Well, not all, but the majority of the highest used ones. And it does not, this GraalVM does not include the full Java VM. It has a purpose-built different runtime, which has only the minimum necessary components for memory management, thread scheduling, and GC. It's called Substrate. So these are from Graal, our main components. Now, how does this image get transformed? So what does building a native image mean? So usually you have your VM, your JDK, your compiled code, and you're undergoing a three-step process with a clear distinction of how the compilation of Java source code to bytecode works. So we will do a comprehensive analysis. We will determine every single class and every single method which is reachable during the execution. This gets written into an intermediate model, and only what the code which is reachable, both code and data, will be compiled ahead of time into a native executable for a specific OS and operating system and architecture. It includes also Heap snapshotting. So in the end, we end up with a binary which has two components, the compiled code and the initial heap. So code part this is the easiest part to grasp. This part has all the classes and methods required to be included in the image because the static analysis found them. So found a path to them. And order inclusion, if it didn't find it automatically, it was included via configuration. Now the image heap is the part which is a little bit more unfamiliar. It's a concept a little bit more unfamiliar to developers. Think that the native image build process, it runs your application for a bit. It initializes some necessary classes and their data, save the state of the application for future use. Then when you run the app in a test environment or in production, the initialized state is already prepared and the application startup is instant. Now, this state obviously has to be written somewhere. So this is stored in the image heap. We can observe the two, and we're going to compare them by collecting this information, by passing in a flag. There are a number of flags which help us with analysis and with determining initialization or in collecting information for reporting and visualization on a dashboard. So if we look at the images, you see here all the different components, and in the end we end up in one single binary. So if we were to compare the two, we're taking the pet clinic. So pet clinic goes at like 60 megs. This is the base image, and then we can see one of the layers as being the GRE. We see it here. Now, the information about each layer, when you use cloud native build packs, for now, it does not print that information. It will be fixed and the issue will be addressed kind of like in the fall. Now, we look at the image, then as we're going along in our layers, we see all the dependencies with whatever we had here. We had here Jackson and jQuery and whatnot, Spring Boot. Now, when we move through the layers, we see the application a lot less. And in the end, we see that this image was actually containing an executable, running an executable jar. Now, when we dive into a native image, we can use a much smaller base image because this is optimized only for our running native images. And we see the one single binary, which is our application. Yes, it includes all the components, and this has not been optimized fully, but you can see the difference. You can see the difference in between the two. Now, when we're coming back through our model, let's understand how do we get this configuration, which will be at the basis of what we're working on. So the native image builder can't figure out all the passes if some languages are language features are fully dynamic. So we need a configuration to inform the native image which classes and method to include in this binary. It's funny, the name is of the tool is called native-image. So you can do it manually, you can do it via a tracing agent, which is recommended if you use only Graal, but you might as well do it via Spring Native. So Spring Native offers native application support for Spring Boot applications. So it will include a plugin for the GraalVM native image builder. It will analyze your app at build time, and it will auto-generate this configuration for developers while computing the most optimal native image config. It does not just generate it, it will look at the most optimal one. Along the way, it will optimize also the footprint and the compatibility to JVM. Now, what is under the hood of Spring Native? There's a general purpose framework called Spring AOT, which is used for code analysis and generation at project build time. So this is at project build time. This is not at runtime. So it will generate a code which is in the Spring factories, and Spring factories will list all the classes which are loaded via reflection. And it will optimize entries that aren't valid in this system. For example, we might have usage of conditional on the existence of a class on the class, if not, off it goes. It will generate configuration for later usage by native image for reflection, resource, proxy, JDK, as well as we're going to see a new feature on class proxies. It's extendable by other portfolio projects and by the larger community, and if you're writing frameworks code or other applications. So what's the key benefits would be we push code from startup to build time. And if the code uses Java constructs like lambdas, methods, references, rather than reflection, the native image static analysis understands the system more easily and produces more optimal images because it's a JDK contract. But when we compare this to the JVM loads everything and discards afterwards. What Spring Native does, it will prepare only analyze only what we actually need. So when we are looking, before we're looking into any ahead of time compilation limitations, we need to know what can trip us up? And it's very important for us to understand that there are four, I don't know, I picked four, there might be others, four important aspects around native image compatibility and optimization. So native image is an optimization. It will reduce startup time and memory, but it will make a distinction between what gets initialized at build time and what gets initialized at runtime. So class initializer is one area we're going to explore. The other one is class metadata features. Dynamic features require configuration, and we need to understand what is happening here. There are some features which are incompatible with closed world optimization, and there are also features which may operate differently in native image. And we have to be aware of them because there could be hidden dangers here, but there are also opportunities for us to learn how to write better code. So if we compare runtime versus build time initialization, so all class initialization code, static initializer, static field init for the app is executed at image runtime by default. Now the native image builder allows us the choice of which part of the app should be initialized at build time or runtime. This is controlled by either native image options, or there is a hint, an initialization hint in Spring Native. What could be initialized at build time? So class initializer for static and static final fields. Some static fields get initialized to run independent data, say enum constant, they're objects, but they also load the data for them. And when we think about runtime, at runtime initialization, we have to perform all the time some runtime checks before static method code. Has this class been initialized? Has this class been initialized? So this is always something which stays on our mind. So who's using initialization? Spring projects, gRPC, Redis, Jackson, just to name a few. So let's take an example of class initialization. And let's bring this application here. We have this application and we have this class. It will call this static second class, creates an instance, and here we initialize the char set. Okay, so this is great. So we are thinking that this should run seamlessly. So when we run it, okay, what does it not like? Oh, I picked up the wrong word, the wrong project. So let's pick this one. We pick this. We're going to run the app. We see it, and it loaded this char set. So this is great. So it loads it, but now we want to build a native. Build a native image. We're not going to build a native image here because it might take us, if I don't share my screen, probably like 3-4 minutes. With Zoom or Twitch on, it might add a lot more. So if we look at things, we're going to build an image as is, and this has failed. Why has it failed? It failed because it could not initialize this class. So did we actually do anything wrong? So, well, this is a static final, it should be known. But when it initializes via reflection, and we have different choices of solving it, we need to understand first why this is happening. So we want to load this char set, but this char set is not loaded automatically. It's not one of the default char sets. Therefore, it won't be loaded. Yes, it was analyzed, but and when we want to run it, the native image will fail. So what can we do? We can use, in this case, an initialization hint, and we're going to say, well, I want to initialize the first and the second class because this is how I actually ran them. Okay, so if we want to do this, and once we run them, then we can run a new feature which showed up with Spring Boot 10. It showed up with Spring Boot 10 and with the release of the GraalVM build tools. This is the opportunity. When we run our test for the class, it will collect all the initialization steps, all the tests. And when we run these native tests, this is a new feature, showed up 8 days ago with 0.10. When we run these native tests, it will build a special native executable for our tests. Yes, it takes some time. We have to be aware of it. But when we run these tests, when we can run them before we even build the image, it gives us the same idea. So I enabled the hint. My tests were failing. I enabled the hint. So now I want to run my native tests again. So if I run them, it has run cleanly. So what we see is that, okay, our tests are clean. And if we build native tests and we have 100% test coverage, we can be guaranteed that our native application will work. So if we start this up, this loads now perfectly fine. So this is good. Let's think about this. So we could have a nuanced approaches. We could use a hint, or we can use, sometimes we have flags where we can include all the char sets. Sure, but that's maybe very helpful once we understand what is happening. First, we want to understand what is actually happening here. So when we move now into initialization furthermore, so that we can see what limitations we might have, let's have a little bit of let's set up the limits. The difference between build time and runtime initialization. So classes stored in the image heap, which were initialized at build time, must be initialized at build time. All the super classes and super interfaces with default methods of a build time class have to be build time by as well. And internally, these classes will be marked that they are reachable in the native image and they're saved in the heap. There is a special case. There is an internal state in GraalVM, which means rerun means build time by accident. So some static fields and class initializers will be evaluated at runtime. And you're going to see how this happens. The runtime initialization is the converse, that's the other side of the coin. So subclasses of a runtime class must also be a runtime class. Otherwise, the initialization of that class would also initialize the runtime class. So we cannot mix and match. Runtime initialized classes cannot end up in the image heap. So as we move to, we can see these things. Let's see if there are any limitations of heap snapshotting. So not every object can be stored in the image heap. So there are 4 top categories, if we want to group them again, 4. So these are objects retaining state from the build machine. So open files like file descriptors, running threads and continuation. If we execute a thread in at startup, and this happened many times in the app server world when people were running threads in lifecycle listeners, and the running threads in a native image cannot be written in, cannot be stored in the image heap. Objects pointing to native memory, let's say a map byte buffer. But then even more dangerous ones are leaking build time info into the native executable. For example, users and passwords, home directories, known random seed. These are very hard to prove if they end up in an image. So let's see first what happens with running threads, and let's see what can happen if we leak information. What are these hidden dangers? So let's bring up now the same class initialization project. So if we look at this, we had this section here. Add this section, and we can uncomment this. If we uncomment this, we run our application. What will it do? It will run also. It will run also this this thread, and we can see that it was sleeping for 10 seconds, and then it says, okay, I'm done. This is all good. So if I'm going to run now, build image, Docker image, I'm going to run it. What just happened now? I can see that this part was executed. So yes, this value was written out. But what happened to our thread? The thread could not be written into the image heap, so it just discards it. The first time I saw it, I was like, what is actually happening here? So what can we do in here? We can now uncomment this in, and we're going to say, please move the second class to be only to be at initialized at build time, and the first class should be initialized at runtime. So once we make this change, we run the application again, we build it, and we expect now a good result. Why? You can see we just decided where we wanted to move these initialization, the classes which were run during build time or runtime initialization. So this is fine. So this, please be aware, it was not written. So suddenly somehow it disappears. But there are also other options where we could leak some information, and this becomes a little bit becomes more dangerous because it could create for us a number of problems. And let's think, let's go through a few of them, right? So we take this multi-threading class. So we take this class, and in the main, we're going to load a config JSON, and in the config JSON, we're going to read this value. Okay, this is all good. Not a problem. We read some configuration values from here from the resources, great. And we're going to run some threads. So now we're thinking, well, I'm not using Jackson anywhere else, only to read my configuration because my application doesn't need it. So how about I'm moving this to a static initializer block? Great improvement. What did I gain here? This gets executed at at build time. Why? Because it's executed at build time, the Jackson libraries are not required anymore at runtime. So they are used and then discarded. So this is interesting. The Jackson libraries are 2.9 or 3 meg. So my application is still the same. So I can run this. So that seems actually quite interesting. Is that going to be for us an improvement? So let's see if we run this. We run it, then it runs some threads, does some work, fine. It took 3 seconds to load and so on. Because we load it at build time, the performance is also faster. Why? Because we don't have to go through the JSON initialization. So when we go through this, how do we analyze this? How do we get to these kind of conclusions? So are we going to do this all the time? No. But should we do it from time to time? Yes. And architects, senior devs would be very interested in finding out how they could improve their application, what optimizations you could have. Plus, you might be writing other frameworks, and in such frameworks, you could, by any optimization you should have, you should not waste the opportunity to do it. So if I collected the information by setting up one of the build flags, yes, it will slow your build even longer, but it collects all this information. Doing it once a day or doing it once in a while would be great. So in the larger images, I see Jackson being here, and I also see my application. Yeah, just a tiny application here. and I can see different packages. I can see what calls what. So this is great. So once I look at things, this is my biggest culprit. So the lowest hanging fruit. This is what gave me the idea to move this into a static block. But if I'm moving now into the improved one, this is now Jackson is not there anymore. Why? Because it has not been loaded. Whereas my application, actually, let's come back to it. My application, again, tiny here. I can see who is calling what through my application. I can see as it is, this is a native image in which we know all the classes and who is the caller and who's the callee. We can analyze this information. So Synco is that having this GraalVM dashboard is a very handy tool for you to bring improvements. So if we're thinking about this, let's come back to our application. So we saw this. Oh, this is a good improvement. So how about we scrap the sample, and we don't build the threads. We're just looking at running these code samples. So this code sample loads. It's the same bit as the previous sample. Just prints out the values, and that's pretty much it. So I'm going to, if I'm going to run this particular application, it should run. Let's run this. Runs fine. It shows us that it loaded some values. So that's okay, fine. It loads some values. We run the image. We build a native image. But I like to, now that I have this ability to write a test and run them over and over again, I can write that. So I have a lot more. Choices. So what can happen here? So what can happen here if I take the same application, but I'm going to also want to serialize this. Now, we optimized our app. Jackson was loaded at startup, and it was simply said, okay, thank you very much. And it was loaded during build time. So now I'm at runtime. I read the file. I'm going to look at this file, but in the end, whether I'm in the same class, I'm in another class, and another developer writes, uses it and doesn't know about what I did, that's always the danger. I'm writing this in a library. I can decide to run this. So I'm going to run my application. Runs fine on the JVM. There doesn't seem to be any kind of problem. But when we are going to we're going to run our tests, let's run our tests. What do we want to do? When we run our tests, we want to decide that we want this class initialized at build time. That's what we decided. We specify the main class. I'm playing with the different samples and using a single project here. We're going to run this, and this is fine. But when we run this class, what just happened? This class we asked for it to be initialized at build time because we thought we have like a really good improvement. So how about we run this, and that's going to be probably the only one of the few we're going to run. But when we run this, something is actually happening here. What is happening is, as one is initialized at build time, and now we are going to look at to initialize it now at runtime because we didn't know about that. This will now get into a limbo state, and we're going to get the following message. classes that should be initialized at runtime got actually initialized during image build time. So this sample was initialized at build time, but now we want to initialize it again at runtime. So now it becomes confused. So be aware of this could be something which could affect us as we're running through our application. Are there any other possibilities of side effects? We were talking about leaking information. So user password, random seeds, and how difficult it is for us to prove this out. So let's look at this security side effect. So if we look at the security side effects, we see this application, we write this code, and we're going to read some system properties. Well, one is the user home. That's from my build machine, but then I'm going to share my code. And here's where the danger is. Or I'm going to load a private key. Happened many times in the app server world, or generating a random number generator where I use as a seed the current time. So if I'm looking at this application and I want to run it, well, let's run this. What do I expect? I expect this to execute properly. And I can see here's the time, and these are the first 3 random numbers. So if I run it again, this was a 3018, a different current time and a different random sequence. So we're saying like, okay, so this is exactly what I'm expecting. But if we are now looking into native images, and if we build this class and we ask for this class to be initialized at build time, it was initialized at build time, what will happen? What was built is what is actually being saved. So it is being saved in the image with that particular number. So if we run the native image, we can run it as many times as we want. It will always give us the same random sequence. So one lesson is don't be aware of them. The second one is don't use time, for example, for a random seed. Because if somebody sees this, they could, it's not easy, but they could decompile the code and they would have always the same random sequence generated each and every time. Same as with the user home. The user home is collected from my map, but it could expose information under this. So we have to be very careful that many times we might be running build time versus runtime initialization. This is all great, but we can bring improvements, but we can also have limitations, and we could and have different behavior, but we could also leak information, and that is something which is very important to us. Now, when we talk about class metadata features, the ones which require configuration. So dynamic features will require a config at image build time for closed world optimization. We have to know upfront because we don't know, as there's no lazy loading, we need to know all the classes which will be loaded via reflection upfront. Some are JDK features, so dynamic class loading, reflection, JDK dynamic proxy, serialization, resource access, JNI. And others are class proxies. This is a new feature which was added with 0.10. Really handy for whoever worked with AOP or works and built security applications. So let's think about some of them. So dynamic class loading, who is using it? So kind of like, and reflection, kind of like the majority of the project we are using on a constant basis. I'm not saying all of us, but many of us use these: Spring, MySQL, Postgres, and so on. JDK dynamic proxies, Spring uses them under the hood, MySQL, Kafka, caching mechanisms, Neo4j as well. Then there's serialization. In serialized objects, we have to know, because we don't know upfront. We have to provide these hints, because otherwise the native image would not know about them, same as it won't know about accessing resources. Why do we mention these two? Is because if we come back for a second to our pet clinic application, we were wondering why pet clinic was actually failing. So what did we do to make pet clinic work? So there are a couple of things. If we just take the application and run it, there are two things which we should know. One of them is, if we look at serialization, we have this test. So this is great. We have this test, and when we have this test, we're going to run our trusted native tests. What are we going to see? We're going to see here that the serialization has failed. Oh, so this test has failed. And as we go along through, through it, we can follow and see which tests have actually failed. So in the end, we can see the test, the vet test. So we said that if a class is initialized at build time, it should include all the classes, all its base classes. If it's a runtime, again, that class plus all its dependent classes. So if we look at the vet, okay, so this failed. The vet extends a person. So person extends a base entity. So what we need to do is we need to add now for serialization a hint. So we're going to add a hint, and the output tells us where it fails, and then we can look through all the classes. It will tell us each one, but if we see that the vet test has failed, we can go through the derivation chain. So we're going to add this serialization hint. So this is one aspect. Now, another aspect is resources. So by default, the native image builder will not integrate any of the resources which are on the class paths. So we have to specify them. If we want to specify them, we can do that in multiple ways. We can provide resource hint, or we can provide the configuration, because this includes not just resources, but it includes, for example, also resource bundles. So if we want to, if you remember the pet clinic, which failed, let's move this aside. This was our pet clinic, which gave us an error. Why was that? So the resource bundle was not properly loaded. So here we have two choices, and I want to show them to you. Either we use a resource hint, or we go to, here are our resources. These are the messages we want to see. But we can go to metainf and add, either via the agent or manually, a bundle, and it says from messages, under the messages folder in the messages, please load these resources for me. Once we make these, these two changes, then our application will, we can build a native application, and it will work just fine. We start it up, and the application will be running just fine. So this is how we fix it. But we have these hints which are always available to us, and we want to use them. How should we start? Well, with a pet clinic, we take the application as is, we run it. First, we're going to see the tests have failed. We add the serialization hint. We run it again. We see that the resources could not be loaded, and it won't fail. It just tells us that we're just not going to see them. And that's okay. So we're going to provide those resources. Now, what did 0.10 bring to us? And it brings an opportunity and also a a hint, if I can use the term, a hint for the future. If we look at class proxies, who's using class proxies? So Spring AOP, Spring Security, Batch, Hibernate, or any class which won't implement interfaces. So if we want to understand how these work, let's move our sample to the side and let's bring this AOT proxy. In here, very simple application. We have an application where's my app? We have an app and we have two controllers. One will say, well, if you hit it on the /with, this is where we want to wire in a proxy. If it's another person controller too, it's without the class proxy. So in aspect-oriented programming, we have we want to define an aspect and we want to use an around aspect. There are many aspects for those of you who are familiar with it, before, after finalization, after exception, whatnot. So we will declare a point cut at this join point. So we said if the person controller demo is invoked, I want to do something. So what do I want to do? I want to define an around aspect in true annotation-based Spring style, and I'm going to do something. I have to pass in the join point here, and I can do something before, after. This around proxy will generate a class on the person controller class. I did not have an interface. This is a major improvement. I've built AOP applications like 10, 11 years ago. And if I were to, until now, if I want to build a native image, I would have to rewrite the code. Now I can just rebuild those applications. They were like plain Spring with Spring AOP, very handy. So if I'm going to run this, well, that's fine. If we run it, what should we expect? Well, I'm going to pick the working one. So the working one says, okay, without, with, without. Why did I leave my pet clinic up and running? So that's where's my pet? Now that's where it is. I left my pets to play around, and you know, they're going crazy. So we have our proxy class, and we have our so this works fine. So this is our hello the class proxy. Okay, that's fine. So we build this. Why did this work? Because we added this AOT proxy. We added this AOT proxy. So this is very handy. But if we wouldn't have known about this, if we would have just run it without it, look how nicely it tells us. So it tells us right away, oh, well, you want to build this app, but you need this proxy hint with this declaration. So add the 010, a number of hints provide like much nicer information. This is very easy to use. I can just copy it and just paste it here. You can just see it. So this is actually great. Now
that's so convenient.
Oh well. This idea of I see, I can use it, and I move on. It's very helpful to me. Now, we build this image, but when I'm going to build this image, I just built this. I just put this hint. So I put this hint, and then I'm building it, and I would expect, well, you know, you told me there's a hint, and there's something missing here. Why is now my application failing? So why is it, what is actually happening here? This has been added new. So it's, as this is work in progress, and I like to see these small cases where this was very helpful, but now I can still not, I'm still not able to start my application. So what should I actually do? So if I'm looking at the things, how about I'm going to start, I'm going to open up my POM. And in the POM, we can enable different modes. By default, we provide a native image mode, which will take care of resource initialization, proxy reflection for the native images. But there's also this native agent, which together with enabling the native agent as provided by Graal, we can run this. Why is this very handy? It's for exactly these edge cases where something is missing. Is this init step going to be fixed in the next patch release? Yes, but if I'm building my own application, I give this as a Spring example, but if I'm building my own frameworks, or I'm taking somebody's framework, or it's some framework X, Y, or Z, I don't know what I'm going to do. So I'm going to run this. And once I run this, I will run it. And I don't have to build the entire image. No, all I have to do is, we mentioned that the AOT, the Spring AOT, will just run for us the generation before we even build the image. What's the difference? It will generate classes for us. And these are the ones which Spring AOT generated. And the other ones are generated by the agent. So at this time, there is no way to automatically merge the two, but I can compare them. So I compare the two folders, and I can see there are some small differences. These small differences, there's actually only one. This one is the one which will be working. So what do I have to do? I have this compare. I'm just going to merge these two. I'm going to merge them. And now that I run the tracing agent, I don't want to run it over and over again. Why? It's a little bit slower, and I don't want to do this. I collected it, fantastic. So I am going to go very neatly to my code and move the merge files under meta-inf native image. I can see all the inits. I can see the demo application. I can see the proxy. You see the proxy for this, the CGlib, the proxy for my aspect. I can see my loggable aspect. This is actually great. So it's a good way for us to see as a sample what could potentially happen. And the hint was a simply copy and paste. The other one is I just enabled this little agent, and then I'm going to do a compare. In subsequent versions, the tracing output with the AOT generate can be, or not can, will be merged, and at that time, off we go. So very handy for us to find out. You can see we have logs to tell us, we have native tests, we can have the Graal dashboard to analyze things, we can have the tracing agent. We always have tools, and we're not going to be lost. Ideally, when everything will be said and done, what the Spring native team wants is to be able to move applications built from JVM to a native image unchanged. Yes, it's a lofty goal, but we're not that far. We're not that far away from it. Now, if we come back to features which were incompatible with closed world, so we saw initialization, we saw dynamic features. Security Manager is not supported. It's in any case, it's deprecating Java 17, and like 2-3 weeks ago, Oracle was tweeting that it will be removed altogether from 18. Invoke dynamic bytecode and method handles. Those are incompatible. Why? Because they can introduce calls at runtime. So, or change the invoke method. there's an exception for the use cases generated by the Java compiler. Let's say lambda in expression string concatenations. They're supported because they won't change called method at image runtime. The last category from the top four we had is features operating differently. So files loaded at build time might be in a different place at runtime. We saw that state where it's like, hey, this was initialized at build time. I expected it at runtime. I don't know what's happening. Running threads, we saw that sample. Finalizers, they're deprecated since Java 9. They were not recommended to be used in any case. Threads, native images that don't implement deprecated methods like thread.stop and so on. Unsafe memory access, and you need to use native debugging and memory tools. Now, if we look at some best practices, and we have one more sample I'd like to go through. So let's list a few best practices when we build Spring libraries or applications. Because when we build native images, we can have two hats. Sometimes we build frameworks. Sometimes we build end user type of applications. So let's keep these in mind when we change code to become more native friendly. So it's generally a good idea to avoid cglib proxies if you don't need it. Then write common code to both JVM and native rather than using Spring native specific code. Graal itself has some Graal specific codes and you can use them. For example, this native detector in Spring can allow us to see, are we in a native image? If you're building an end user app, I would not recommend it. So it's always like everything, it's like in architecture, I like to say it's not white or black, it's gray. It's sometimes the truth is in the middle. If you're building frameworks, it might be very important for you to detect whether you are in a native image or not. So in general, as a good practice, if you build end user apps, try to avoid it. Favor functional approaches like Lambda and method references instead of reflection wherever you can, because these constructs are automatically understood by the native image static analysis. Very handy for us. A few more. If we want to, if we can move reflection to build time where possible, and this is where Spring helps us a lot, and Spring helps us do it. But in some cases, we might want to rewrite the code and move the code into static blocks. You saw I was playing with the different initialization patterns, and I could specify I want this class initialized at build time. I want this. You can specify these fields, but if you, as a good practice, is start with the default. Let everything be initialized at runtime. Let Spring help you. And if you want to move them, instead of using flags and saying initialize at build time, yes, of course, you can do it. But try to maybe think, can you maybe improve the code and move this in the code? One, you don't lose such changes. Second, it gives you the opportunity to improve the code. Last best practice, avoid complex initializers, because these could lead to security vulnerability and deadlocks in the JVM. Where could such a sample happen? If we come back for a second to our security side effects one, let's take this shared utilities. We're building these shared utilities. So I'm building this, and of course, this is a made up example. So we read some properties like a user home or the random number generator, and they're built in a library. So we build it, and that's maybe cool, or we build that library for some time. Now, whoever is using that library, and it might be called in some initialization chain, might not know about it. And there you go, we introduced a security vulnerability. This could happen in this way. It could happen with loggers which are not initialized correctly. Think about the fact that we might be crossing library boundaries, and then we might not know what is actually happening. Now, let's look a little bit at a sample. So the sample we had, I've built some a little sample, which should, let's move this a little bit, slide in here, and let me take this troubleshooting sample. I played around with this. Okay, and it's a, come on. This machine is getting slower and slower. So we build this application, and in this application, we have a bear interface. Bear's very popular in my family, and we can define a JDK proxy. We intersect the talk method, and when we run it, we might, what are we going to see? We're going to see here that it intercepts the talk method, and it will not intercept the eating method. We have the UUID, and we bring back the char set. And we just want to run them. So that's fine. When we run this, the application should run fine. So I'm running this application. This should be okay. Seems all right. I'm going to run the application. This is all good. I've put all the hints and everything looks fine. So now I'm thinking, hey, maybe I have to reuse this across the enterprise when we're building things at scale, or I want to share them, or I want to share them across my project. So what should I do? Should I go in now every single class and define hints, serialization, and so on? Sure, there could be a few, of course, this is a made up example, but these could be some shareable hints. So if we're looking at some shareable hints, let's close also a few of these apps. Let's bring in a shared hint. So what can we do? And now we see the flexibility which we have with Spring, which we have with Spring Native. So all those hints, I can copy them and put them in a separate, build a separate library, a simple class which will implement native configuration, and I can declare all the hints. So, oh, this is like fine. I can build this library and then reuse it. We wanted to understand why those char sets were not loaded. So yes, we can use the hint, but we have also an alternative. There is a flag which will say add all char sets. If we know that we build this, we can just add some custom hints, and we list 4 hints. These will now be part of the library together with the hints which we declare, just so that you see an alternative. If we just will have solved this with the flag, you would not have understood the build versus runtime initialization. So when we build this, seems very nice. So I'm going to build this. It's a simple library. I build this library. Okay, should be running fine, and should be running fine. So now I have it. Great. How about I come back and want to use them? So I had my troubleshooting application. I moved all the hints away. If this would move faster. Docker is acting up after some time with native images and with Docker 3. Please be aware when you see Docker using up a lot of your CPU, as it happens here. It's like around 18 gigs. We started at 10, 2 or 3 times a day. I'm just going to restart it. A bit annoying, but it is as it is. So we have the application. So no hints. Great. How does this work? Why did this actually work? Well, it worked because in the POM file to the AOT plugin, so to Spring AOT, we said, in addition to the hints which you are aware of, please take our custom hints and use them. So use them, and then my application doesn't require them. So with hints, you can see them. You can apply them on any class which is annotated as a Spring Boot application or configuration. You can put them in a separate library and declare them as with standard hints, if I can use the term. And you can also set up your own. If you're looking into frameworks or applications for which the Spring team has not provided all the possible hints, first they're looking at Spring Boot and Spring and all the Spring ecosystem. Then the heaviest used frameworks like Hibernate and whatnot, Kafka, and so on. And there are always things which are still work in progress. So you have the ability to either bring your own. If you find something, bring your own, send a PR, it gets committed, and you contribute to the community. But we have this entire flexibility for the usage of hints. Now, before we end, one last peek into 0.11. 0.11 is scheduled around Spring 1, and Spring it will bring a very interesting feature. Moving away from the annotation-based configuration, we could change to a functional configuration where we register being with the application context, and we're using Lambda. So should we now rewrite our code? Because this is going to be easily understandable by native image, it's going to improve performance. No, because the team is working on how this can be optimized. To recap, it would be perfect if things would just move by changing the configuration. But until that happens, and even without that, it's very important for us to understand class initialization, metadata features, featuring compatibility, and features which might operate differently. If we could have, let's say, days from now, weeks from now, a seamless, unchanged Spring Boot app to Spring Native, there are things which we need to be aware of, because if we don't think a little bit ahead, we might be creating security problems or have different behavior, which nobody can solve for us. Nobody can really understand that we're generating a random number, for example, which we can leak, or that we ran this thread, and at that time that result is not written in the image. So with this being said, thank you for watching. I put a repo out. This is the repo which was at KubeCon Plus. You take samples piece by piece, how you set up your environment, how you run every feature, as well as class initialization. It runs through the samples we ran today. Well, most of them minus the class proxy, which is too new. I didn't have the time to update it. You can see the samples, run them, don't get lost in them, between either the Graal side or the Spring Native side. And you can see the Spring, you can see the pet clinic and a few other samples. So thank you again.
Thank you. I need to learn like your teaching style. Like it's great. Like it's just easy to like stay focused on what you're doing. Also, Zaffy's was asking if the slides could be shared.
The slides can be shared if I can make a PDF. If you have a way to share them, however you want, I can make them available in a PDF.
Maybe they could go in the GitHub repo.
In the GitHub repo for in the public GitHub with the code.
Would that be?
Well, it is, but the slides have the Spring and the VMware logo, and this is my private repo. So I would rather, I have no problem sharing it, but I would share it through something which the Spring team would prefer, rather than, sure, my private samples, that's cool, but as a deck and as a good corporate citizen, I like to share what we do, but I also want to do that in a reasonable way. You can let me know offline and where that would make sense, but it's absolutely not a problem.
Is that something you'd be, after you put it online, something you'd be willing to post about on Twitter?
I can, yes, absolutely. I can.
Okay, because then that's a place for someone to easily go afterward to find it.
For the samples, yes. For the PDF, if we have any site which we can host that, just let me know, and I will share the PDF with you later today. And by the time the recording shows up on YouTube, you can put the links if you like.
Cool.
Okay.
Yeah. So yeah, Zappy's, I'll figure out putting it somewhere with when I post the video for today's talk, which will be on YouTube on VMware Tanzu. You'll also be able to access it from tanzu.tv/tt/58 after I upload it. So yeah.
That's going to be very handy. Well, thank you to everybody who joined. I cannot see participants while I'm talking. I cannot reply to chats, but I hope this will spur on people to explore this this great opportunity here. We did not get into samples, and the first sample is how fast will your serverless application start? That's an entire subject of, and many of our clients are really interested in this. Imagine now I have applications, my pet clinic starts in 100 milliseconds, not in 3 seconds. It opens up new avenues. That's why it's interesting as a technology. It would just build it from left to right, would be okay, so why? But if it opens things up, then that's going to be very, very helpful to us to use it in CLI application and serverless, but it might also be giving whoever's watching or clients or Spring Native users ideas as apply it wherever your imagination leads.
Also, Zaffy says, excellent session, and I agree.
Thank you.
It's great.
Thank you. I hope it's helpful.
Serverless, yay.
Serverless, yes, I can show you a sample if somebody wants to hang for 60 seconds. Let me share my screen again. So if I'm looking at this, let's make this a little bit larger, right? Let's look at this for a second. If we are looking at a function, this is a function, a Spring Cloud function deployed in Knative. It is the Cloud Native runtime, the Tanzu Cloud Native runtimes implementation. And it runs in the public cloud in a cluster. So I have this service, and I provided a couple of revisions. So one is an 80/20. What's the difference? So if we were thinking that canary deployments were in the past, were, oh, version 1 is my application, version 2 is my application change. How about if my canary is now a native application and I want to run this and build this? I've used this for, the idea came to me when we were doing some client work. And how about we do this? So to see, where is it? It's back. So let's see how quickly this starts. If we bring up K9S, and I'm going to send this some requests. So this should start, and it's an 80/20. Expect this to start. I'm going to run this a few more times. And I'm lucky, it's at the second call. Let's see. What is happening here? If I'm looking at this function, it started in 2.8 seconds. Okay, that's 1 second. But what if I'm going to start this now as a function? It started in 97 milliseconds. So the time in the serverless world, the time to the first request is very important. Imagine I have a batch file which comes in, or request and I want to spin something up. If I start now a Java application in the cloud in 97 milliseconds, imagine how many opportunities I open. This is where we go. CLI applications. What is for CLI? How quickly they respond? Imagine for CLI, well, click this and I'm waiting 2 seconds. No, native images built with that. And there are many other opportunities.
That was fast, and thanks for showing that. That's cool.
Thank you.
And I like how your window is green. It just makes everything look like it's working.
Well,
all things are working because it's green background.
It's a green background because my youngest child, my daughter, her favorite color was green. And everything when she was little, she liked green, some green toys. Then she had green things. So I kind of like to keep a few things, you know, same as bears are very popular in the family. But it's also visible. I don't know, maybe I'm wearing glasses and I see the contrast better.
Oh, and Zaffy says, thanks for the sneak peek.
Oh, if you follow this, if you follow that repository, I will update it with 0.10 and with the samples from today. Some I just finished in the last few days. But join us for Spring 1. At Spring 1, we're going to have 4 sessions. 2 will be hands-on, will be, sorry, like self-paced. 1, simply how to build a native app, and 1 a little bit more elaborate to understand hints and initialization. But there will be also 2 instructor-led workshops. 1 is like an introduction to see the whys, what we have to look into. The second one will be similar to today for advanced users, but some of the things I'm talking today will be solved by 0.11. So I have to change the content. This evolves so fast that you have to keep pace with it.
Yep. And for everyone, just go to spring1.io. It's our spring conference, and it's the first week of September, and it'll be virtual.
Yes, it's we hope to see everybody there, and there are going to be some really I saw a list of some of the talks and workshops, and there will be some really cool things happening.
And then I'll be emceeing part of one of the days. So everyone's going to be watching that part of the day, I think, for the keynote. So it's going to be stuck seeing my face again.
For me, you don't see me unless you show up for the workshops. As this technology evolves, we have to think that it's also not just going to translate into how we improve and build native images. It will help us improve Spring and Spring Boot as well, because this ahead of time generation and understanding and then functional configuration, if we can build this upfront, even for whoever builds JVM application, or maybe somebody cannot build native application, they would stand to benefit from the work of this team. This is very important to think for the future. Yes, Spring is the preeminent web development framework, but think how much this evolves, and any lesson learned is not applied only one place. It is applied in multiple.
Well, thank you so much. And yeah, I just realized that your Twitter is actually a private Twitter.
My Twitter is, yes, I will open this up. I was not as much as opening up Twitter. I follow things. I'm more on which projects I can contribute on small little things, more on that side. But I follow what's happening on native. Like I have a separate list for just native things on Twitter. Things are changing like by the minute.
Or the second for something. It's just crazy. I don't know how to keep up with all this stuff. I've just learned that I can't, and I'll try what I can do.
Well, I think that in the end, what is interesting is we have to understand some good principles, some things which should be foundational things change. But if we understood a distributed system, or if we understand the concept of aspect-oriented programming, they can help us in many other things, whether we do them that or not. Things change, tools are changing, Spring changes, Java changes. Look how much, even if you take a Java 8 application and you build it with 11, and we have to run them with 17 now in September when LTS shows up, we see improvements only by just rebuilding. But imagine if we just look at the new features. But object-oriented programming or aspect-oriented programming is still, the concepts are still the same, and we learn as we go along. That's why I like that little sample on AOP, because I see this, it helps me, then it still has a delta. Then I see the tracing agent, and oh, what do I have to do? Just merge two files? Come on, right? And my application runs. So these things are making you look a little bit. By this, you understand also what is happening. And I don't know, maybe I'm a more practical person, but we need to get the basics right, be aware that there might things where we might have issues, and then it's up to us to explore.
Awesome. Well, thank you so much. And yeah, whoever's
Thank you.
attending, go to the workshop at Spring One. So yeah, have a good day, everyone, and hopefully we will see you next week.
Yes. Bye, everybody.